Okay, when the last video cut off, we were getting ready to construct our histogram. So this video will be part 2 of this series, constructing a histogram. And we may have mentioned this, but histograms are good for presenting data as grouped in ranges. And so here we have data for time in minutes in which runners have finished a 10-kilometer race. And right away I'm thinking that this will make a good title for my graph, so I'm going to go ahead and place that across the top. This is the finish times of runners in a 10K race. And this pencil is not going to work for me anymore. And so from this list, there must have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 runners in this race. And so what you want to do is start to group these runners' finishing time into ranges. Because if you made just one big range of all their finishing times, like the lowest one here is about 76 and the highest one is 100 minutes. So if you made your graph with just one range on it between 70 and 100, you would have every runner in this race with just one bar on your graph, and that's not what we want. So we want to start making smaller ranges so that we can represent this data in a way that makes more sense to us, that gives us more information. And so the guesswork here is just playing around with how you can make your ranges. And so looking at this data, the spread between 70 and 100, I could break that down by fives, and I think that that would be okay. But looking at the space available to me, I have went ahead and grouped this out in ranges of 4. So between 76 and 80, 81 to 85, 86 to 90, 91 to 95, and 96 to 100. And so the next step that I did once I decided what my ranges would be is to determine or count the number of runners that fell within that range. So the times between 76 and 80, I had 1, 2, 3, 4 runners that finished in that time. There were 5 runners whose finishing times were between 81 and 85, 3 between 86 and 90, 2 between 91 and 95, and 3 between 96 and 100. So I knew I was going to place 1, 2, 3, 4, 5 bars on my graph. The next step for me was to figure out the space that I had so that I could make evenly wide bars going across there. I had 20 spaces. I needed to put 5 bars on there. So that divided out, 20 divided by 5, meant that my bars were going to be 4 boxes wide. So I made them 4 boxes wide. The scale for my y-axis, the range for this data was between 0 and 5. Once again, I had 20 boxes. 20 divided by 5 meant that every 4 boxes was going to be equal to 1 on my scale. So starting at 0, counting up, the first mark is 1. 4 more gives me a place value of 2. 4 more was 3. 4 more is 4. And finally at the top is 5. Then it was just a matter of graphing the bars on here. There were 4 runners between 76 and 100, 5 between 81 and 85, and so forth. Now you should, on your graph, color in these bars, but for the sake of time, I'm not going to. The last step you want to do is go ahead and check according to the TALKS acronym to make sure that all the elements are on your graph. You have a title, your correct variable is on the correct axis, labels for each of those axes. The key are the range values underneath the bars, and then scale. All of my bars are equally wide. There are no spaces in between it because that's the difference between a histogram and a bar graph. Nothing's hanging off the side, nothing's hanging off the top, and it's taking up 50% of my space. The last scale factor to consider is that I've counted evenly going up the Y. So all of those things are good, so your graph is accurate and appropriate.